All right, good afternoon, ladies and gentlemen. Let's get to work here. So we have a series of 4 proofs we're going to look at this afternoon, kind of walking through and proving it. And since by poll and kind of by you guys are saying that the 2-column proof is really suiting your style well, that's what I'm going to try to use tonight. So when you're looking at a proof like this, or really kind of now this more advanced level of proof, the most important thing you can possibly do is make sure you have a really solid plan in place about how you are going to prove this. In the end, if you have not justified in your own head why in this case MP and LO are going to be perpendicular, then really writing the proof is going to not be worthwhile. So let's do that first. So this is just very informal. This isn't really the proof itself. It's a plan for the proof. And what we're trying to accomplish in this step is simply to understand why this line LO and this line MP are going to be perpendicular, meaning that they're going to have to meet at a right angle. So we should question to ourselves, well, how do I know angles are right? Well, it has to do with measurement. If I can show that the angle here, which I will now call 1, and the angle which I will now call 2 are both 90-degree angles, that means they're both right angles and therefore perpendicular. So that gives me a clear sense of what I have to do. I really need to end up showing that the measurement of angle 1 is the same as the measurement of angle 2, and they're both equal to 90. That's going to tell me that angle 1 and angle 2 are right. And that in turn is going to tell me that MP is perpendicular to LO, the statement I was actually asked to prove. Well, so how do I do that? Well, if I have to show the 90 degrees, I have to involve measurement at some point. So really, I have to probably use this idea that there's a line here and this measures 180. But let's look at my givens. In fact, I'm going to label a couple more angles. I'm going to call this angle 3. So LPM is really just angle 1. MNO is angle 3. So that's angle 3, and that's angle 2. My given statements actually reveal a lot about the strategies I'm going to use. 1 is congruent to angle 3, given statement. 3 is congruent to angle 2, given statement. So 1 and 2 have to be congruent by transition. Well, let's think about this. If angle 1 and angle 2 form a line, therefore are supplementary, and therefore their measures add together to make 180 degrees, and they're congruent, meaning their measurements are the same, that means they're splitting the degrees equally, meaning, hey, that's going to be 90 degrees each. If they're both 90, that means they're right angles, and therefore we're perpendicular. We're in business. That's how we're actually going to end up solving this thing. Proving this thing. Okay. So let's do a quick review, make sure we're all on the same page as far as the plan goes, and then we'll proceed into the proof. So I have to show 1 and 2 are congruent. I'll probably do that by some form of transition because 1 and 3 are given to be congruent, as are 2 and 3. Therefore, 1 and 2 should be congruent. So that's really my big stage, after my givens, of course. That's going to be my big stage 1, showing that angle 1 and angle 2 are both congruent. If they're both congruent, I have to show the measurements are the same. Step 2 is really going to be my linear pair piece. And then step 3 is showing that the measurement of angle 1 and the measurement of angle 2 are both 90 degrees. Okay. So let's get into it. If that's going to be my general plan, let's execute it. So as I stated before, I'm going to be writing this proof in a 2-column style. That's what a majority of people have indicated as the style they're latching on to the best. So if you're planning to write this using, say, like a floating style proof or maybe a paragraph proof, that's totally cool. Just know the steps are going to be the same, format different. Okay? So let me format my 2 columns. Here I'll put my what's going on. And over here I'll put why it's happening. In other words, statements here, justifications on this side. Okay, so first and foremost, I got to get my givens into my proof. And again, in terms of relabeling and ease for this presentation, I'm going to rename my angles. So definitely one thing that's given is angle 1 is congruent to angle 3. LPM is congruent to MNO. So let's get that in there. Okay, so again, structure first. We always got to go structure first because we have to tell you what you're looking at before you tell you characteristics of it. In other words, we have to tell you what's the deal with the angle before we actually talk about measurements. I'm going to go ahead and write this in as a given step. Okay. I'm not going to go to measurements yet, which I know a lot of people did in their proof. I know I'm going to use transition coming up, and I don't need measurement to do that. You can transition really with anything, and that includes just angles themselves, the structure. So let's go to our second given. Angle 3 is congruent to angle 2. Okay. I said my first stage was really trying to connect angle 1 and angle 2, but I set myself up to do that. If 1 is congruent to angle 3 and angle 3 is congruent to angle 2, then it should be true angle 1 is directly congruent to angle 2, and that's going to be by transition. Okay. So 1 is the same as 3, 3 is the same as 2, therefore 1 and 2 have to be together. Now I know looking forward that I'm going to have to use measurement in some way because I'm going to go to linear pair, so here's an opportunity. If I know 1 and 2 are going to be congruent, I can certainly claim their measurements are going to be equal. Now, you may be asking me, hey Mr. Collins, how come you didn't tell me about the measurements of 1 and 3 or the measurements about 3 and 2? Well, that's pretty easy. I don't really care about angle 3. Angle 3 was just being used here as a transitive link to get me 1 and 2 together. 3 in this whole entire proof is really vital, but also very unimportant to the final piece of getting these two to be perpendicular. So I'm not going to actually use that. In terms of justifying this measurement, we can go definition of congruency. Okay. And I think we've taken that line of thinking as far as we can. So the next stage of our proof was bringing these together as a linear pair. So let's do that. Angle 1 and angle 2 are supplementary. Again, naming the relationship that's completely based on the structure of linear pairs. If I know that they are supplementary, then it should also be true that the measurement of angle 1 plus the measurement of angle 2 equals 180 degrees. And that's going to be by the definition of supplementary. Now this is completely necessary because remember we're trying to get this to be equal 90 degrees. If we want this to say, hey, these angles are equal to 90 degrees, we need them into an equation as fast as possible. This equation that comes from our structure is going to be the best way to do that. Now from here I just can't say, hey, they're 90 degrees. And the reason I can't do that is because, again, when you're writing proofs, you got to be writing for an audience that you know knows less than you do. Excuse me. So jumping there is too big of a leap. Like algebraically, we had to set up this equation so we could solve it and show directly that angle 1 and angle 2 have the equivalent value of 90 degrees. So let's take away from the proof. Let's step away for a minute. Let me explain to you what I mean. If I just showed you this, and again, this isn't part of the proof, I'm just trying to explain my points. If I showed you this, and then wrote this, and then wrote this, oh, pardon me, and then wrote this, we're making an assumption here that's not clear. You're going to ask yourself a very natural question, especially at this step right here. What happened to the y? But if I tell you this above, okay, and then maybe right here I insert a step where I'm actually performing a substitution, okay, and then it would flow more naturally. That's the reason I can't jump to just telling you that these angles are equal to 90. There's many sub-steps involved, and those are steps that you're about to see. Those are steps you're going to have to show if you want a complete and studious proof. In other words, we have to algebraically show at least a progression of these pieces coming together. So again, I'm going to switch colors here to try to make this more clear that we're kind of looking at a different idea. So what I mean is this. Again, it's all about how it looks. It's not about what you know in your head. It's about how the proof actually looks on paper. So I'm going to perform a substitution. Replacing angle 2 with angle 1, which I can totally do from this step right here, step 4. I know they're the same, therefore exchangeable. But now when I'm actually trying to solve for measurement angle 1, it makes sense. Because this would be like x plus x equals 180, which is 2x equals 180. Divide by 2, I can conclude that either one of these pieces is equal to 90. Okay. And that's just going to be by solving. Okay. Well, if angle 1 is equal to 90, and angle 1 is the same as angle 2, I can then directly conclude that angle 2 must also be equal to 90. And that's transition substitution. I'm going to go with transition just because of the way I said it. Okay. Angle 1 is the same as 90. Angle 1 is the same as angle 2. Therefore, angle 2 is the same as 90. Well, if 1 and 2 are both 90, then I know angle 1 and angle 2 are right angles. And that's going to be by the definition of right angle. Okay. And our final step is if they're both right angles, that would force the line MP to be perpendicular to the line LO. And that's going to be by what it means to be perpendicular. Okay, so I hope this helped. Okay, I hope you guys are studying hard. This is a great problem to look at and evaluate and really think about looking forward to our test tomorrow. Hint, hint, nudge, nudge. Again, think about the 3 big steps here. We had to use transition to get angle 1 and angle 2 to be the same. That happened purple. We used the fact that this was a line to get an equation so we could hopefully solve for 90. That was the red step. And then actually changing around so it physically looks like an equation I could solve to force angle 1 to be 90. Therefore, angle 2 being 90, they're right and perpendicular. Right? So that's all I have for this green proof. And again, it was the one that's on green. Do keep in mind that all the worksheets, all the proofs, if you didn't pick up on class, maybe lost it on the ride home, they're all downloadable on Edmodo right now. So please make sure you're logging on and taking care of those as you know you need to. All right, so have a good night. Study hard. I'll see you guys tomorrow.